Welcome to our Notes on Pulleys video 2. So today's lesson we talked about pulleys on a table and pulleys on an incline. And so we're still using the same formulas except they have little pieces of modification. A pulley on a table is when you have a pulley on a table and you've got one block that is on the table. We refer that one to that mass of that block as M2, and it's being pulled by the hanging block, which we refer to as M1. The block on the table also experiences friction between it and the table. So the F net is going to be calculated differently in this instance. So now that we have friction that we have to account for, we are going to calculate our acceleration by taking the f of g minus the f of f. And we're still going to be dividing that by the total mass of the two blocks. The tension equation is still tension equals f of g1 minus m1 times the acceleration that you just calculated. Okay, so notice, let me move this, that the f of g is going this direction and that the tension is going this direction. Now before, on the regular pulleys like this, I don't know if you can see that on the screen, but before, this is the pulley system that we were working with. We would take f of g2 and subtract it out of f of g1. But we no longer have these two that are working on one another. They were in the same line of the pulley, but this is the direction in which the pulley is going, and FG2 is not in the same line of that anymore. So that's why we subtract out f of f and not f of g2. So that is the main difference between the table pulley system and then the regular pulley system that we talked about before. So let's do example 3. Suppose that a 200 kilogram mass on a table is being pulled by a 350 kilogram mass hanging off a table, and they are connected by a cord passing over a massless frictionless pulley. If the mass on the table is experiencing a force of friction of 50 newtons, what would be the acceleration and the tension? So we're being asked to find acceleration and tension. Okay, let's do our free body diagram. So I'm going to use red to calculate my f of g. This is my f of g1. This green is my tension. The blue is my f of f. And f of n comes back to the picture. Now notice f of n is on this box that's on the table, not on the box that is being pulled down, because that is tension. Okay? So there's our free body diagram. We can find our f of g1 like we have always done, and that is taking the mass of the hanging box. So our mass of the hanging box is that, the second mass that's mentioned. The mass that's on the table is the 200 mass. I'm sorry, that's our mass 2. The 350 is our mass 1. Okay? So the mass here is 350 kilograms, and the mass here is 200 kilograms. So I can take 350 and I can multiply it by 9.8, and that is going to give me 3,430 newtons, if I remember correctly. So we are going to first go ahead and find our f of f. Oh, wait a minute. We don't have to find our f of f because look, they gave it to us in the problem. So our f of f is 50 newtons, which makes it easy because now I can find my acceleration, which is going to be my f of g1, remember, minus my f of f. And so my f of f is 50 newtons. My f of g I just calculated a few minutes ago was 3,430 newtons. I'm going to divide all of that by the mass of my two boxes, which ends up being 550 newtons. And so my acceleration ends up being, let me get my calculator, 6.15, or you could write 6.1. That would be fine too. Okay, and that is meters per second squared. I'm going to use 6.1. Now I have to find my tension. Remember, my tension is my FG1, which is 3,430 newtons, minus my M1, which is 8. Oops, I'm sorry, I was thinking of another problem. 8, here I go again, 350 kilograms times the acceleration that we just, I'm going to use that one, calculated. And so whenever we do that, we get 1,278 newtons for tension. Okay, so that is how we work that problem. And so here is another problem. It says suppose that a 5 kilogram mass on a table is being pulled by an 8 kilogram mass hanging off a table. They are connected by a cord passing over a massless, frictionless pulley. If the table has a coefficient of friction of 0.3, what would be the acceleration and tension of the system? At this point, I would encourage you to pause and work this problem by yourself, and then you can come back on and push play and watch me work it, because this is your example for yourself, because I just did the example 3 with you. That's my encouragement. So go ahead and pause and do your thing. Okay, so if you're back from the pause, we're going to go ahead and we're going to write our free body diagram. This is our FG1, and I'm probably not going to talk. Now this formula is a little bit different than or this problem is a little bit different. In this one, we actually have to calculate f of f, which is, notice, they gave us the coefficient of friction. So we're going to have to find our f of n. So because we have to find our f of n, then this problem we're going to find f of g2 because we didn't have to in the last one. F of g2 is 49. So it's the same up here. So f of n equals 49. Okay, I hope you got what I got. So now we are going to look at pulleys on an incline. So whenever you have a pulley on an incline, the block on the incline is going to be our M2. And so the effigy on that one is going to be effigy 2. And so it's our hanging block that's going to be our M1. Now remember that the effigy goes the same direction as the effigy X, and they are not going to be equal to each other. So let's remember that in this type of example, our f of n changes into f of gy. We have to calculate a y and an x component on the incline. And so we end up with an f of gy and an f of gx component. So we're going to find those using trig. Okay. So the formula is the same formula, we just have to tweak it a little bit. The f of net is going to be the difference between the hanging weight and the x component of the incline of the box because we now have an angle. So from the box, on the incline is going to also create some friction. So we have to subtract out now the f of f and the f of gx. We find this with trig. And we still divide by the total mass of the two boxes. And our tension is found the exact same way. So let's do a problem. First, we're going to draw our free body diagram. And our f of g is also our f of g2. Notice our friction, our tension is here where it has been before. Our f of g2 is not a part of the friction from the position that it's at, because remember, we are about to make things do some crazy stuff. We have an f of f that we have to account for and an f of gx, the x component, which is also the horizontal component. And then we have our f of n, which is still up here. Okay? So in this, if we want to find our f of n, we have to find our f of gy, our y component. And if we want to find our f of gx, we had to find our x component. Okay? And we had to use trig to do that. And if we're finding our f of f, we have to find our f of n. So this problem says that we have a 7 kilogram block that is going to accelerate up a 35-degree incline with a mu of 0.28. Now, if it is being pulled by a 6.5 kilogram block that is hanging, we want to know what the acceleration and the t are. So let's go ahead and identify our masses. So our box that is hanging is 5.6, and our box that is on here is 7 kilograms. We can find our f of g1 and our f of g2 by doing the simple 6.5 times 9.8. F of g2 is 7 times 9.8. Now, that is going to be our hypotenuse in our problem. So I'm just going to be not using decimals as much as I possibly can. And this is 64 newtons. Okay? So, before I can find my acceleration, I've got to find my f of g1, which I have found, and I'm going to go ahead and start putting it in my equation. I've got to find my f of f, and then I have to find my f of gx. Okay, and all that's going to be divided by the total mass, okay, which is 6.5 plus 7 is 13.5 kilograms. All right, So let's do the first thing here. Let's go ahead and find our f of n, because if we find our f of n, we can find our f of f, and it takes about 2 steps. So my first step is to use trig. So I have my hypotenuse. This is my hypotenuse, which is f of g2. My angle is right here, and that angle is 35 degrees. If this is my hypotenuse and this is my angle, this is my adjacent. And down here, the f of gx is the same as my opposite. So to find my f of gy, which is also going to be my f of n, remember, because I've got to find my f of f, which is going to be my mu, which they gave me as 0.28 times my f of n. All right. I've got to use cosine of the angle equals the adjacent over the hypotenuse. So I solve for h, I'm sorry, I solve for a. Okay, I just rearrange the formula. When I do, a, which is also my f of g y, equals my hypotenuse, which is 69 newtons, cosine of the angle 35. And so what I get when I do that is 57 newtons. That is going to be the same as my f of n right here. So I'm going to put 57 newtons right there. I'm going to multiply that by 0.28, and that gives me 15.96. I'm going to round that up to 16. So my f of f is 16 newtons. I'm going to erase this because I need the room. Okay. You can rewind and pause if you didn't get that. So I've gotten my f of n and my f of f. My f of f is 16 newtons. I just calculated that. Now I want to find my f of gx. My f of gx is my x component. My f of gx is the opposite side. So I am going to use sine of the angle, which is the opposite over the hypotenuse. When I rearrange, I'm solving for my f of gx, which is also my O. And so I'm going to take 69 newtons times sine of the angle, which is 35 degrees. I said 65, I meant 69. I don't know what I said. And so I get 39.5, so I'm going to round that to 40 newtons. I'm going to erase that because I need the space. So this is 40 newtons. And so let's put all that in the calculator. Remember, you had to put this in parentheses. So 64 minus 16 minus 40 is 8 newtons divided by 13.5 gives us 0.59 meters per second squared. Tension equals 64 newtons minus the mass of 6.5, mass 1, this is f of g1, times the acceleration that I just got, 0.59. And you get 60 newtons for your tension, and that is how you calculate it. And I'm going to toggle over to the next page. You can go ahead and do this one on your own, and you can come to class and ask for questions. That is the end of the tutorial. Bye.